Question 8. So here we want to find these three forces, EK, DE, and KL. So they find those three internal forces. We've already resolved the reactions. We've applied the load. So there's two ways you can answer this. You can maybe pause the video now and try and solve all three forces in one go, or go through and follow my solution, and I'll tell you where to pause when I'm finding each individual force. So pause the video now if you want to have a go at solving all three forces in one go. If not, then carry on watching. So the first force we're going to find is the EK force. So we've split our framework in half, and notice that EK is just the only force that's pointing in a vertical direction. It's horizontal and vertical, whereas the other two forces are both just pointing in the horizontal direction. So what I want you to do is to pause the video and resolve EK going in the Y direction. So I'm going to resolve the forces. I'm going to make the forces and resolve them so that EK is pointing downwards. That makes it a bit easier. So the left hand side will be a positive. I can see that EK needs to swing through 45 degrees to point downwards. What else can I see pointing downwards? Well, the 12 is, and the 6 is pointing upwards. So since the 6 is pointing upwards, and I've defined this in this particular occasion that downwards is the positive, that gives us a -6. EK needs to be times by cos 45 because it's swinging through 45 degrees to get to point downwards, and 12 is all pointing downwards. We rearrange that, and you should find that you get EK is going to be -8.49 kilonewtons. Next force. Next one to deal with is the DE force. Okay, so we're going to deal with this by solving, taking moments about K. So if you can, pause the video now and see if you can take moments about K and then thereby find DE. So taking moments about K, what does that give me? The first force I can see is the DE force, which is making a right angle with at the pivot there, at the K pivot. So there's the pivot, and it's making a right angle. So we got 1 meter away for the DE. Notice D is going from left to right, whereas around here you can see that the clock face is turning from right to left. So that means that we got a minus DE times 1. This 6 is over here, so we want to pretend that it moves up to this position here and then measure it. So it's going to be 1, 2, 3 meters away. So we've got 6 times 3. We arrange that and it'll be easy enough. DE equals 18 kilonewtons. So I've resolved forces in the Y direction. I've taken moments. It therefore suggests the next thing I need to do is to resolve forces in the X direction. So if you can, pause the video and give that a go. So I'm going to resolve all my forces in the X direction. And I can see that the load and the reaction don't play any part in this. I've got the KL force pointing directly left to right. I've got the DE force pointing left to right, and then I've got their buddy, the EK force. So EK is cos 45. So you can see that that's a positive. That's a positive. EK needs to swing through 45 degrees to point horizontal, in this case, in this direction. So that would be a positive too. The force we're looking for is the KL force. So we now substitute in our previous results for EK. Have a look at them. And for DE. And then you're going to get an answer of -12 kilonewtons.